Hey guys, welcome back to another fantastic episode of Ready to Die Fighting. I'm Chris. You see this light blue piece of paper, so you know what we're doing. We are talking about Earth and space. Let's get into it. This is not to scale. I explained that in the first video about just the size of the universe, size of the solar system. It is not possible to draw this stuff to scale on paper. So just keep that in mind. There's our sun. And then here, I'm just going to put in the middle here, this is beautiful 8,000 mile roughly spherical 13.66 trillion pound planet that sits about 93 million miles from the sun at roughly, let's see, roughly 66-degree angle that we call Earth. We've got a moon, just one moon, that sits about 240,000 miles away from us. And that's basically what we look like in space. Basically, not to scale, of course. Let's see, here's our equator is going to be roughly here. All right. And at this point, this part's going to be dark because it is facing away from the sun and there's nothing to light it up on the other side. And that's our planet. There's Earth. Only planet that we know of like it. And what's cool about Earth and ogres is that it's like an onion. There are many, many layers. If we start from the outside, let me erase that, or maybe put it up a little higher someplace else so it's a little bit out of my way. Let's give myself just a little bit more room. Let's say 8K. There. All right. So there are many, many layers. And if we start from the outside, we've got our atmosphere. And within that atmosphere, there are actually 6 layers to that atmosphere. I'll probably do a separate video explaining all of them individually, but just know that there's 6 layers of them. The exosphere, which is the outermost one, this is where basically the final last little bit of our particles of air and gas, whatever, start to kind of drift off into outer space. It's hard to come up with an actual boundary because that's where things are kind of just dissipating and you get into the actual vacuum that is space. And this happens at roughly 100,000 kilometers. Oh, whoops. I wrote that kind of weird, didn't I? 100,000 kilometers. Or I think it's 620 miles is what that converts to. However, that's not the line that most people consider to be where you actually hit outer space. There's a separate line called the Kármán line. I don't know how it's pronounced. I don't know if I've ever heard anyone say it, but it's spelled like this. Kármán line. And that sits at, basically just remove some zeros, and it's, I think it's at 100 kilometers in height. And that is the point where, like if you were in some sort of airplane or whatever, that's the height that they can no longer achieve lift. this is a point where you need to get some kind of rocket boosters to get further up. Anything below that, you can just get in a plane and fly around, and just the speed and aerodynamics and all that. I don't really know how airplanes exactly fly. I know it's like the air moving over the wind creates some lift. So you can get that below that. Once you get to the Kármán line, that's no longer possible. And this is the point that we consider to be space, generally accepted as space. So for reference, if we look at something like, let's go over here to Mount Everest, highest peak in the world, that's only going to be sitting at 8.8 kilometers. The International Space Station is sitting at orbit around, let's see, we call that ISS. That's sitting at orbit around, actually I should probably put that lower. Yeah, it's about half of it, but whatever. 408 kilometers. If a pilot travels up to 81 kilometers, he or she has then earned their astronaut wings. So you're technically an astronaut before you even get to this Kármán line. So that's how high up that is, for reference. And then go a lot further, because this is only 100 kilometers. And then I said that our atmosphere ends around the 100,000 kilometers. There you go. So that's how far things extend. Again, huge. Everything's huge when we get into space. That's the outside. If we go inside the Earth, we have the Earth's surface, which is the crust. And this is the thinnest layer by far of the Earth. But this is where we live. This is where the trees grow. This is where we dig and can plant things. This is where the plate tectonics happens to push up and break up the ground and make earthquakes and mountains and valleys and all that fun stuff. That's as far as we can even dig. We can't really get past our crust, because even though it's the thinnest, it's still very thick. After that, you get something called the mantle. And that's just a hot, miserable place. I think it's like a semi-solid, sort of a lot of movement. There's a lot of activity. That's where volcanoes are born. And then once you get further down, you get the core. And the core has an inner core and an outer core, and it is made primarily of moving, rotating, super hot, molten iron and nickel. So nickel and iron. And that is really important. Also, just a little fun factoid. I think I told you guys, what was the number? The temperature of the sun. I think it was like 6,000 Kelvin, let's just say, roughly. Super hot. The core actually reaches temperatures very close to or similar as the surface of the sun. Insanely hot. That blew my mind when I learned that. It's like something can get that hot in our core. And that is residual from when the Earth was created. It was a fire pit when the Earth was first born, from the massive amount of energy from that drunk bitch Thea who crashed into us. And then also just all this friction, all of the weight of the world, the gravity and just sheer weight pressing down, that's creating a ton of heat. And so with all this friction and movement, it is also generating electricity. So if you took any electronics classes or you know about stuff, then you know that where there's electricity moving, electrons moving, you have a magnetic field. And so something that makes Earth very, very special and very, very fortunate unlike our buddy Mars, we have something called a magnetic field. And that magnetic field, along with our atmosphere, is what protects us from this angry son of a bitch who is just constantly shooting radiation and plasma and ultraviolet rays, all that. We're constantly being bombarded with it. But thanks to this magnetic field, the Earth being essentially a giant magnet, we have this, I don't know, I don't know what they're called. Protons, electrons, magnetic particles, whatever they are exactly. They're traveling around and enveloping in us in this massive field. It's constantly moving and changing. The solar wind, which is all those particles that the sun's shooting out, it is kind of like wind. It's blowing through here, and most of it is deflected, wraps around and away. But it also, if it's strong enough, and it varies, it will push and change the shape of this and kind of push it back. Sometimes they even kind of get caught up in this field and kind of whip around, and we end up getting hit with it. I think I'll make a separate video on this because it's a lot, and it's also something that's important to a lot of preppers, because these electromagnetic fields these radioactive rays that are hitting us, the ones that get sucked back in and actually hit us, it causes the aurora borealis, the northern lights. I think there's also southern lights, but I'm in the north, so that's the ones I know about. And that's pretty, that's cool. But the downside of that is it can have a really big impact on electronic devices. And so it is a legit concern that we could get impacted with some big ones that can cause some very serious problems to our grid, to our cars, to our everything. It's happened in the past. It will happen again. But we'll talk about that in a different video. The other thing I wanted to get to is that keep in mind, as I said in the last video, everything, what's going on with my pencil here? Everything is moving. This is liquid and it's moving. So it's not always just dead center here. Sometimes it's maybe right here. Maybe it's over here. Maybe it's changing shape. It's all this stuff is happening, which means as this shifts, this magnetic field is going to shift. So while we have a geographic axis right here that is pretty constant at the 66-degree mark, the magnetic poles, which is where we're coming out of here, that shifts with this movement. So sometimes our magnetic North Pole might be here. It could be here. It could be over here. It could be here. Sometimes they completely flip, and this is the magnetic south, and that's the magnetic north. That has happened 700,000 years ago. It happened. We weren't really we weren't able to monitor that or anything, but there's evidence that has happened, and it could happen again. What effect will that have on us? I don't know that anyone knows, but it's kind of expected that it shouldn't be that big of a deal. So your magnetic poles can be, and often are, very different from your geographic poles. And how does that relate to us, and why is that important? Because if you're looking at a map like this one, we use north and south, and we've got these grid lines. I've done a video, if you don't know how to read these type of maps, I have definitely done a video on how to read maps with a compass and all that. So review that if you want to know what that's about. But when we make our maps, we draw our maps according to geographic north and south. All these grid lines are geographic north and south. But if north is here on this piece of paper, but the magnetic north is someplace else, the compass doesn't know about geographic north. It's reacting to the magnetic north and south. So it's following wherever the magnetic poles are moving to, wherever that may be, that's where the compass is going to point to. And so that's why you have declination. That's what this is right here. Every map, certainly topographic maps, I don't know that road maps have them, but topographic maps definitely do. It's going to show you the, I guess you could say, true north, the geographic north, and then magnetic north. So for my location, where this map is located, in relation to this chunk of map, the magnetic north is -7 degrees. So you have to adjust your compass to that if you want your map and your compass reading to be accurate. And that's what that means. That's why it has that. I believe I've done a video specifically on that. If I haven't, leave a comment and maybe I will one day. But that's why that happens. And as I said, this is constantly changing. So this map I printed out last year, it probably is still ballpark -7, but it might be -6.8. It might be -8. It is fluctuating. It fluctuates every year, every day. This thing is moving. So if you have old maps, you need to, the map itself maybe didn't change very much, but you need to update the declination. There's websites where you can do that and figure that out. There's charts and whatnot. But before you go on an adventure, make sure you've got the most current map and the most current declination for that area to make sure you don't get lost. See, I told you this stuff relates to prepping and outdoors and all that. It really does. So we're at about 16, 17 minutes now. So I think this is a good place to end. Was there anything else I wanted to cover with this one? I think that's it. So we learned about the different layers, how the Earth is kind of built, how it's an onion, our axis, our magnetic poles. There's also a geomagnetic pole, which is kind of a combination of the two poles, as the name implies. If you take the average of where this moves around, the geomagnetic pole is kind of more like a region, and it's going to move along with the magnetic poles because, it's all moving, but it's more of a region, the circle that these guys are moving around in. I don't know that that's particularly useful to us. I mean, realistically, the magnetic pole and the true geographic poles are kind of what we deal with in I think every other aspect, but that's just another one that if you hear that term, that's what that is. So yeah, let's end it here. Thanks for watching. I hope you guys enjoyed, and I will see you in the next video. Like and subscribe.